Today in our lab, we will test ClusterXL failovers. Before testing the failover, we will need to set up testing connectivity from admin laptop to smart management server. For this, we will configure routing on the laptop and on the SMS. Today, we will see how ClusterXL works. We will do manual failover from lab gateway number 1 to lab gateway number 2, and then we will failover back from lab gateway number 2 to lab gateway number 1. To do some interesting testing, we need to set up a test connection. The test connection should go from laptop to Ethernet 0 of lab gateway number 1, then to Ethernet 1, and then should go to LAB-SMS Ethernet 1. Right now, this connection will not work because we don't have routing. We don't have a static route on the laptop. Laptop doesn't know how to reach LAB-SMS Ethernet 1 interface, and LAB-SMS will try to send the return traffic directly through Ethernet 0 because it will see MAC address of the laptop and IP address on the laptop as directly connected. To fix this problem, we need to add two static routes. First static route will be on the laptop, and we will show how the laptop should connect to the IP address of 172.16.1.100. And on LAB-SMS, we also add a route back to the laptop IP address via Ethernet 1 interface. So this way traffic should be symmetric. It should go back the same way as it goes from laptop to SMS. SMS should send this traffic to Ethernet 1 of LAB gateway 1, and then LAB gateway will send it through Ethernet 0 back to the laptop. When we will do a failover, this traffic flow will take another path. The traffic should go from the laptop to Ethernet 0 of LAB gateway number 2, Ethernet 1, and then go to the Ethernet 1 of LAB-SMS. LAB-SMS will reply back to the cluster IP address, and this return traffic after the failover should go through our second gateway and return back to the laptop. This is the traffic flow which we should see during our testing. There is one additional thing to configure before we can change routing. Right now we have connectivity between administrator laptop to smart management server direct through VMnet 1, and traffic goes like this. And this is a symmetric traffic flow in both directions. We don't need any additional firewall rule to manage a smart management server. But if we change routing and if we will send traffic through the firewall, this will require firewall rule. In addition, we should remember that after the routing change, we will need to connect to the smart management server not through Ethernet 0, but through Ethernet number 1. Okay, and the first step would be to log into smart management server the same way as we did the last time through Ethernet 0 IP address, and we will add a new firewall rule to manage smart management server through the firewall. Let's go to security policy and let's add a new rule below. Set up a rule name. This is rule for our laptop. Destination will be smart management server. We don't have an object for this. Let's create a host object. That's some meaningful name. With this name, we will exactly know why we have this IP address for this host object. And we will allow any service. This should make the change. Now we can install policy. Okay, installation is successful. Let's create a route. This will be the route on our laptop. To find out how to add route, we can just make route help. This is a really easy instruction. We will do route add, put our destination, mask. This is a host route. Then we should put the gateway. As a gateway, I select IP address of firewall cluster in management network. To check the route, we do route print. And here it is. That's our host route. We can exit. The next step for us is to configure static route on Smart Management Server. Let's connect to Smart Management Server with a SSH. To configure a route, we should switch to Clish. Then the command is set static route. We can press question mark to find the instruction. First, we specify the destination network. It's our admin laptop, so it's 192.168.43.1, and then there should be prefix that's 32 for static route. Then next, hop gateway address, and the next is the address of our firewall cluster 172.16.1.1, and we select on to enable the route. At this point, our SSH session to Smart Management Server disconnects because the traffic flow changes. Let's reconnect. And you see that now it doesn't work because we are connecting to Ethernet 0 of our Smart Management Server. Let's try again, but this time we will specify not Ethernet 0 IP address, but Ethernet 1 IP address, 172.16.1.100. We accept the fingerprint. Okay, now we are connected. We can check the routes. And we see that the route to our laptop goes through the firewall cluster IP address, and the interface is Ethernet 0. Also, we can notice that Smart Console is not connected anymore for the same reason. And now we should reconnect to Smart Console using that IP address. In Smart Console, we will be able to check logs and see that incoming interface of all our connections to Smart Management Server changed. Let's go to log and monitor and switch to logs. In logs, we can see that our new connection now going through Ethernet 0 of the firewall, and it is not going direct. We see the source IP address of the laptop, and we see destination IP address of the Smart Management Server. If we scroll down, we will find the SSH connection. We use this SSH connection to check routing on the smart management server. Before that, the SSH connection from laptop to smart management was not going through the firewall, it was going direct. Before we will make a test for failover, let's log into the firewall and try to capture some traffic through the firewall. To capture traffic, we will use a standard tcpdump command. Before that, let's confirm what are the interfaces to the source of the traffic and destination of the traffic. Traffic to the laptop will go through Ethernet 0. Traffic to the smart management server will go through Ethernet 1. And let's catch, for example, 100 packets. In the tcpdump command, we specify that we don't want to see names of ports and IP addresses. We want to capture traffic only on specified interface, Ethernet 0, between host of our laptop and host of smart management server. I do not specify source or destination IP address. I want these two IP addresses either as source or destination in the packet. Now we start the capture and we already see that there is some traffic between smart management server and the laptop. This is traffic generated by Smart Console. We finished our testing connectivity setup. Now we can send traffic from administrative laptop to smart management server. Let's check our current cluster status with the cphaprob start. We see that firewall number 1 is active, firewall number 2 is standby. Let's check on the second firewall, cphaprob state, and here we have local standby and the other one is active. Let's bring these two firewalls side by side, make clear and also clear here. For testing of failover, we will generate some traffic. Let's make simple ping of our SMS 172.16.1.100. Okay, now we can make another TCP dump between the laptop 192.168.43.1 and SMS 172.16.1.100 for ICMP only. Here's the traffic. If we will do the same TCP dump on the other firewall, we don't see any traffic. Traffic goes only through one of the firewalls, not the other one. To initiate a failover, we can do ClusterXL admin down. After the command, we immediately see that ping is now going through the other cluster member. cphaprob state shows that local firewall is down, and we see the reason for this is admin down pnode. Pnode is a problem notice. If we do cphaprob -l list, we see that state is problem and device name is admin down, and it happened just 28 seconds ago. Now we can stop cpdump and let's bring the firewall back up. It is ClusterXL admin up. cphaprob state. State shows that our firewall is now standby, not down, and cphaprob -l list doesn't show any problem notice. It shows us init. Init is okay. We don't have any p node for admin down. Everything is good. To bring this gateway number one again as a active firewall, not passive, we will have to issue the ClusterXL admin down command on the gateway number two. XL admin down cphaprob state shows that our firewall is now active, and we see the failover from member 2 to member 1. This firewall goes from standby to active. cphaprob state shows that local firewall is down on gateway number 2. Again, we can see the same p node, cphaprob -l list. That's admin down p node here, 29 seconds ago. Let's bring the firewall back up, and with this we will be back to initial state before any failovers. ClusterXL admin up. And we see cphaprob state shows that the firewall is now standby. This is the full failover cycle, so we failover from gateway 1 to gateway 2, bring gateway 1 up, and it became standby. Then we brought down firewall number 2, firewall number 1 became active, and the other one is down. And right now we are back to active standby as we were at the start of the failovers. I think you noticed that when we did a failover, gateway number 1 did not became active firewall as soon as we removed the admin down p node. This is a normal behavior. By default, firewall will not retake master role, active role, as soon as it has all the problematic p nodes removed. This behavior can be checked in Smart Console if you go to the cluster member and then you switch to the ClusterXL VRP. At the bottom you see that upon cluster member recovery, what should we do? We either maintain current active cluster member or we switch to high priority cluster member. In different scenarios you may want different settings in this part, but I would recommend keep it as maintain current active cluster member, because the most common reason for failovers is interface failures, and interface failures may happen frequently. Frequent interface failures when some SFP, let's say, is faulty and it's flapping up and down, cluster will follow the SFP, and it will also be failovering back and forth as soon as interface changes state. Maintain current active cluster member will ensure that the stable cluster member is handling traffic until the faulty one is completely fixed and checked. So highly recommended to keep it as it is. Let's now see what happens if we have interface failure on a firewall with a ClusterXL. For this, we will go back to CLI and we will do the command to periodically check the cluster status in CLI. The command will go as follows: watch -n means every 2 seconds, and then we specify the command. The command is cphaprob state, and then grep, and then the sync IP of our firewall. And here is the output. Let's reopen the second firewall. And do the same command, watch -n every 2 seconds, -t the command, cphaprob state, grab and the sync IP of the other cluster member. So we see one is active, the other one is standby. Now let's go to the VM settings and let's disconnect one of the interfaces. Let's do not touch management interface, and we, let's say, shut down the external interface of the firewall, like disconnect. We see that the state now is changed to down and the other one changed to active. Let's bring the interface back up. Oh, sorry, the gateway number 1, and this now connect. Now it is standby, the other one remains active. All good. Let's do now second failover. We will disconnect interface on the gateway number 2 firewall. It's active with a problem. Now it is down and the other one is active. And now we connect again. We see that it switched to standby. Let's repeat the exercise one more time, but this time we will pay attention not to the cluster state, but we will pay attention more to the Pnotes. Cancel the command. For example, we will make cphaprob -l list. We see that there is no any bad Pnotes. We bring the interface again down, disconnect the interface, and do the Pnote again list. We can see that there is a problem, and that's device name. Local probing, that's problem. Do we have any other problem? Let's check. Yes, we have interface state check, and we have a problem here. If we bring the interface again up and redo the command, local probing is now okay, and interface active check also is okay. Today we do some testing for ClusterXL failover. We checked how failover works with the ClusterXL admin down and admin up commands. We checked how ClusterXL reacts to interface failures. Also, we set up our testing connectivity from admin laptop to SMS. During the next video, we will check even more about ClusterXL failovers with the TCP session handling. We will search the connection table for the same connection in both cluster members, and we will see how it reacts to cluster failover.